All right, everybody, good morning. We did go over the final test problems here. Is just a going over it as a class. I didn't want to record those. But here's our problem as we have been doing it. So hopefully you're continuing in from last time. What happened last time? I guess let's go back real quick here. Let's do a previous problem real quick here. C had an interesting problem here. This was a toughie, wasn't it? You guys remember C from last time? If you have your notes with you. What time are we out of here? 35 or 45 after? 35? Yeah, okay. So might have to do a little bit more work here. Okay, just to remind you guys, here's what happens in mathematics, is that we stumble upon sometimes a process to do stuff in. Like, hey, you know what, look at this. I can do it this way. And so we do it this way for a while, sometimes years and years. And then someone else comes along and says, hey, wait, look at this. I think there's a faster way to do this process. And so then we find out the faster way to do the process. That's what we want to do today. We want to find out the faster way to do this because letter C, did you guys like that? Did you guys like all the steps there? Was it a long problem? Yeah. It was a long problem. And so what did we have to do? We had to give some space for the x squared and the x. We had to factor out the 4, and we actually put a denominator of 4. We divided by 2, we squared it, and then we put exactly the exact same amount on the other side. Not the exact same number, just the amount that's being added. We're good. So here's what we're gonna do. We're gonna do the same process again, and maybe one more time. And then we're gonna try to figure out, is there a faster way to do this? That's what we want to do. So next, here's our problem for today. Let's go with it. So just to remind ourselves how to do this here, and then we want to see if we can find a faster process. Talk to me. Tell me if this is good. We're going to leave a little space. Good there? Anybody done with the problem already?
I didn't start like that. But can't you just factor it out right away? So you can get 2x plus 1 times x minus 5. Does that not work?
Yeah, it should work, and it's factorable. If it's going to be nice, problem should be factorable. Our issue here is that we're trying to find the vertex, not so much factor. Vertex is what I'm trying to find. I'm trying to find the axes of symmetry or the axes of parabola. So start off this way, I think, and then we factor out the 2. This time the 2 nicely goes into 12, so it just becomes a 6x. Everybody good there? So notice it's just a process, right? It's a cycle process here. We take the 6, we divide that by 2, makes a 3, and we take the 3, we square it to bring it into here, right? We have formed ourselves a perfect square trinomial. What do we subtract on the other side in order to make it the same? 18. Not a 9. Have to subtract 18. Are we good there? Subtracting 18? Subtracting 18 here, and we are almost done. Boom. This will be x. Oh, and then the easy part is that little 3 becomes the term at the end. It's the stuff right before we squared it. Let's see, minus 13. Vertex is, anybody? It's always the opposite here, -3, and it's always the exact same. So -3, -13. So I know kind of how this graph looks like, but the first thing I know is 1, 2, 3. The vertex is all the way down here. We good? That's one thing I know real quick. Second thing I know, this guy is facing up because that 2 is positive. I know this parabola is going like this. It's facing up. If it was a negative, it would be facing down. Next thing I know if I were to plug in zeros, oh, this would be a good one. If I plug a 0 into here, a 0 into there, I give myself an answer of 5, is that right? So the y-axis is very easy. 1, 2, 3, 4. Very easy to know what the y-axis is.
Isn't the axis going to vertex going to be negative?
Oich, thank you so much. How about doing it correctly? -3, -13. Y-axis, so easy to get. Y-intercept, so easy to get. And the graph, I'm not trying to graph here, right? It's the vertex here. So I go like this, and there's my graph. Now, the axis of parabola or axis of symmetry is this little line right here. It's the one that cuts it right in the middle. But cutting it in the middle means you're going to have to go through the vertex. And vertical lines always have the x coordinate as their, so you change that coordinate into an equation. That's what you do. Boom, there's your x symmetry. That one's the line that divides that parabola exactly in half. Okay, we good? All right, I think we have just enough time for the next one here. So I'm not sure where this originated from. Someone came along the line and said, you know what? D is perfectly cool, takes a long time. C is a long time. It's okay. Is there an easier way?
Yes.
Easier way, here it is. So, and I'm not sure if it's algorithmic, because in algebra and the formal process of algebra really happened in India. And Al-Khwarizmi is the one that's considered the father of algebra. Indian mathematician. And I think it's from here, but I'll have to check on this. So here it is. How about this? In order to figure out a formula, we got to put numbers in there. But since we have to use generic numbers, we put variables. So A, B, and C are some kind of numbers. They're generic. Let's see if we can follow the pattern here. And you guys tell me if this makes sense. So what I'm going to do, I'm going to separate the C from the rest of this, give it a little bit of space. I'm going to factor out the A. Remember how I did it last time? If I factor out the A, what do? Yeah, we plug in the value that we factored out, we plug it into the denominator. Boom, awesome. Okay, what do? We take the B over A, is that right? We divide it by 2, or better yet, we multiply it by 1/2. So B over 2A is what we, squared goes right inside there.
Write it that way, or?
It's gonna be written that way, yep. Okay, so real quick here, we're learning an easier way to do it, right? We're learning the formula way of doing it. But we do have to create a formula. Once we create the formula, we're like, yay, we're awesome, right? So now we have ourselves a B squared over 4A squared, is that right?
Oh, it's the squared.
What do we subtract on the other side to make it the same?
Twice that. Oh no, A that. So it'd be A times B squared over 4A squared.
So off to the side, yeah. We got A.
AB squared over
Yeah, AB.
Whoa, this seems more complicated.
4A cubed.
Okay.
Oh boy.
Hey, there you go. We're trying to develop a formula. A's are going to cancel, right? Oh, B squared, right? B squared. The A's cancel, but one of them, right? There's another A in the bottom, right?
Oh, so B squared over 4A.
So it's going to be minus B squared over 4A. Let's finish it up right here, because that's all we need to get to. How about this? A, X, what is it, plus what?
No.
Almost there, Abe.
Oh, B over 2x squared. No, that's at the end.
It's B over A.
Not B over A, close.
No, it's B over 2A.
B over 2A, it's right before you square it, right? It's this guy here before you square it. plus all this stuff over here. And you know what? That stuff is, some people, some textbooks actually make a formula out of this as well. And some people will see how do we do that. So in math world, there's a debate of how we should write this. Dylan.
Up there, when you were moving the b squared minus 4a out of the c, so whatever, that bit, weren't you supposed to multiply it by a?
Yeah, multiply by a here just to show it.
Oh,
The a's here, and then it cancels with one of the bottom a's.
the bottom is 4a squared originally.
Okay, so debate in the math world. You guys ready? How do we write this? Do we write it as vertex is, ooh, tell me, we do the opposite, right? So we negative b over 2a. Good there, it's the opposite of this guy. And then some people put in c minus b squared over 4a. Some people do that as a formula. And some people, what they do is they say, listen, you know what? That's too hard, plus we need more stuff in it. It's actually much easier just to do this. This is a funky way of writing it. You guys ready for this? We're gonna plug in whatever we get for x, we're gonna plug into y.
I like the C minus B squared over 4A.
Yes.
I like that one.
C minus. That's much simpler. Yeah.
And so I have textbooks that go both ways. I have worked with textbooks that put in a c minus b squared over 4a.
Is this like the quadratic formula for this kind of problem? Yeah, I mean, plug stuff in this formula every time.
Uh-huh. Yeah, so let's,
It's a ton of puns. I know,
Uh-huh.
I think that.
nah, few people think that. Okay, so let's go with it. The easy way, you guys ready? E, we're gonna go E. So the easy way now. Can you give me, I think that should work out well here. Okay, give me the vertex. And I'll put axis of symmetry, AOS. So I think I have a formula. Formula is, I first have to figure out this. In fact, it's easier to do the axis of symmetry. You go x equals negative b over 2a. So talk to me. This makes sense here. So negative of my 10, right? Multiplied by, on the bottom, 2 times 1, because a value is 1. And I give myself, everybody okay with the negative 5?
-5,
Yep.
We take that negative 5, we plug it in as a negative 5 into the problem itself. And we get ourselves negative 5 squared plus 10 times negative 5 plus 14. 25 minus 50 plus 14 equals 11. Okay, I'm going to go with negative 11. Okay, even better. Okay. Okay, real quick here. Is that much easier than taking the 10, dividing by 2, squaring it in, subtracting this? Vertex is negative 5 comma negative 11. Axis of symmetry is x is equal to negative 5 10. Okay, faster way of doing it. We good? Sure, sure, absolutely.
Me? Yeah. Oh. I'm thinking about.
10 times
I know it's not.
The 10 times negative 5.
10 times negative 5. Thank you.
You told me that.
Okay, good. You guys tell me when you're done here. Oh, let's see, 10 more minutes. Okay, I think we can finish up. Got 2 more kind of different ways to set it up here.
What if there's a way to get to the answer? Plug it into a battery.
Hey, just look at the problem and instantly know the answer.
You just write equals and then put the problem on the other side. It's not a problem.
Okay, F. How about if we have a multiplier on the outside?
Oh,
It's not that hard, people.
yes it is.
Oh, wait,
Wait, no, can't you just factor it in now?
but then you're gonna factor it back out. You just save this in.
Yeah, so let's see, we got the 3/5 on the outside, right?
So can't you just solve it normally and then multiply it again? Or does that not work?
Well, 3/5
Ooh, that's
is
interesting.
A,
It's a multiplier. Uh-huh.
This is A, A is one.
Inside
Well, you
there.
multiply
3/5
in,
gets
3/5
factored
X
in.
squared.
Yeah, it has to be
3/5
factored
is
back
A.
in.
Oh, wait, you
The
do have to
3/5
factor
is
that.
in.
Yeah.
Oh, that's horrible.
And then is that a 6x?
6x, uh-huh.
So 6, why?
So 18/5, is that right?
Yeah.
Yeah.
And that's a 3 at the end.
Okay.
Ah, welcome to fractions.
I
No.
Wait, negative, is that minus 3?
Is that positive?
Minus 3 at the end, I believe. Uh-huh, yeah.
It's a -3?
Just gotta stack that.
That is it.
No.
This is horrible.
Are we good there?
It's a
Next.
stack fraction, it's so mean.
Hold on. So stack fraction, so undo it. So it's this right here, and then all we do is we take the reciprocal, and it's undone.
Oh, wait, that was really.
Undo a stack fraction. 5s are canceled. Negative 18/6.
Wait, that's a thing?
Perfect.
That can.
-3. Now, the question is, do you want to plug it into the original function or the one that we multiply the 5/3 into?
I don't wanna use B again, let's plug it into the function.
Let's plug it into the, well, original function or the one that we kind of, okay, that's what I'm thinking too here. Let's plug into the original. Because at least that way we're going to do all the work and then we just multiply with 3/5.
I kind of feel like the other one was easier.
No, we're gonna get to do 18/5 squared on a fraction.
Yeah, so could you imagine
Have
the other,
fun.
yeah, the other way would have been 18/5 divided by 2, right? Squaring that. And then in order to subtract it out, you got to figure out what that is times that in order to undo it.
Have fun, you two, we're gonna do the other one.
Whenever you have a fraction, that fraction, as long as you multiply it by the negative reciprocal, that's how you get it out.
Not by the negative reciprocal, just by reciprocal. Yeah. Okay, so how about a 9 here, minus 9 minus 18 minus 5? Minus 14, I think, is that right?
Wait, why are we plugging all these numbers in?
Uh-huh, because we have our X value for our vertex, we need the Y value for the vertex.
Yeah, I know.
Yes, 3/5 times -14.
We're plugging in back to the original function, not the one that we multiply the 3/5 into, because then we have to deal with more fractions here. But on that one, we can actually deal with just one fraction on the outside. What's the 3/5 multiplying?
Oh boy, I need to math and I forgot. -14.
-14. Ooh, that would have been a nice, not very nice thing to compute either here. So 13, what is that, negative?
Times negative, if you do it times -14/1.
Cool, we good? So I think I'm done. Axis of symmetry is X is equal to -3. And I'll just put capital V for vertex. Vertex is -3, comma, -42/5. Are we good? Cool, okay.
Question does not have to do with the homework. When will the homework for all of this?
I will send it to you guys by the end of today here, because I'm almost done tweaking it here. Yeah, homework sheets, I haven't given you guys a homework sheet yet. We haven't finished 5-1, but I'll send it to you guys tonight, at the latest tonight.
You have a lot of files
Oh,
to have right
crap,
now.
he forgets to do it and then he sends it to us like later and then we have to do
all of it in a way shorter amount of time, and that would be bad.
Yeah, that's better, procrastination.
Procrastination.
No.
Let's go with that.
How about we just don't get them all in a row?
Oh,
It's better for once we agree.
Wait.
Why would we go to Canada?
Because Canada's better.
But there's so many other
Nothing
better
happens in-
places.
Okay, hold on, let's.
let's go, guys. Find the standard form of
Who needs home
a
care?
quadratic.
We're all gonna die one way or the other.
You're already dying.
We're all terminal. So then we have to enjoy mathematics while in the process. So one of two ways to do this, guys. First things first is, yeah, I think I'm gonna have to do it by this way. So on some of the homework, you guys will just have a graph, but essentially you're still getting a vertex and a point, right? It's still the same as opposed to a graph here. So vertex and a point, here it is. You have yourself a vertex of, I'll put V for vertex, 5, 12, and a point that's somewhere on this parabola is 7, 15.
What do we have to find the standard form, so ax squared plus the x plus b?
And the standard form, let's go back over here.
Or is it the other one?
No, it's the other one here.
Oh, okay.
So real quick here, standard form off to the side. There's no point to find the quadratic form because then we have to do all the work here. But this is the stuff that we use for graphs, right? Right here. That's the one we like for graphs.
Quote unquote like.
Like. So what we do, we go over here and we say to ourselves, you know what? We pretty much have almost all of it. We don't know A yet, but I can plug in the H really quick here.
Yeah, and say.
And I can plug in the K. That's easy enough. That's super duper easy enough. Good. Boom. Next, I have this thing called 715. And I need to know what A is. Because that's my missing one.
That's on the parabola line.
Uh-huh.
The parabola is all the same x value. So if the x value is 7, the parabola is 7, right?
Wait,
I'm so confused.
Hold on. No. It's okay. Hold on. We'll get there.
I just don't listen to him.
I have that right here. I have 512, right? And then I have the 715. It's like right over here. So we could do this if you're at a graph and it's easy to do this. We could do that right here. You moved out 2. That means 4, but oh man, hold on. But we only went up 3. Bummer. So if it's easy, you could do it graph-wise. If it's more difficult, we go like this. Isn't that the plug-in of x? And isn't that just f of x? So we have ourselves an equation. We're going to say this. If I plug in a 7 into my x value, I should get out a 15 out of my y value. We good? See if this makes sense? It's just a coordinate, right? It's a point. We already have the function already, don't we? Function sitting there, except for that little a value. So in this case, I plug in the 7 for x. I plug in the 15 for f of x. The only thing I'm missing is A. I'm missing A.
3 or 4.
Perfecto. 2 here. We're going to square the 2. That becomes a 4. Let's put it on the outside. Subtract the 12 gives us a 3. Divide by 4. And how about an a value of 3/4? Are we good? Boom. Now let's write it over again real quick here. This is f of x is equal to 3/4 x minus 15 squared plus 12 and done. And we're finished with 2.1.
I like this, I like the formula. Thank you.
Uh-huh.
You saved me so much pain. Thank you. Do you want me to
Oh, yes, please, leave,
leave on
leave
the desk?
on your desk. That's fine. I'll spray down the desk. So you don't do that.
Thank you.
So. All right, guys, have a good weekend, and I'll send you guys the homework sheets
Thank you.
soon. Yep, sometime tonight. Dylan?
Negative b over 2a is the formula for finding h, right?
Formula for finding h, correct.
And then the formula for finding k of the vertex is C minus B squared over 4A.
That's the formula, or the way the book presents it is you just plug in what you get for x. You plug in that into the original function. And then when you get the answer for that, that would be your k. See you later, man. Have a good weekend. Thanks.